night. TECH, but TikTok. It was cute. So we'll definitely edit this part of the recording out of the video, but I'm gonna go off camera. I'm gonna be muted. If you all need anything, just send me a chat or say my name, and I'm not shy to pop on, right? And have fun. And then of course, Jamie, once you start seeing people enter in the room, you know that we're live, and then you can just start right at noon.
Perfect.
Okay.
Thank you.
All right, well, I see people starting to come in. So Jamie, why don't I turn the floor over to you to kick things off?
All right. Hi, everyone. Thank you for joining us for ASME's Tech Talks. These talks are a monthly 1-hour webinar series focusing on topical subject matter in a variety of mechanical engineering disciplines represented by ASME's technical divisions and technology groups. I'm Jamie Hart, Senior Manager of Technical and Engineering Communities at ASME, and we are joined by Frederick Constantino, Standards and Certification Project Engineering Advisor, who will be moderating today's Q&A after the talk. As you think of questions, you can submit them through the Q&A box within your Zoom screen. Frederick, I'll turn it over to you to introduce our speakers and kick things off.
Thanks, Jamie. Hi, everyone. Thank you again for joining us. I'm Frederick Constantino, and I've been a mechanical engineer with ASME for over 16 years. I am the staff contact for the Model-Based Enterprise Standards Committee, as well as several other standards development committees, such as our Y14.5 Dimensioning and Tolerancing Committee. Both committees you'll hear about today typically hold regular meetings that are free and open to the public. If you're interested in getting involved or attending a future meeting as a guest, feel free to contact me or Jamie, and we'll assist with getting you details. And with that, I will now introduce our speakers. Ralph Hill is a retired engineer from Westinghouse Electric Company, and following his retirement at the end of August 2014, he formed his own consulting company, Hill Engineering Solutions. He is the current ASME Plant System Design Standards Committee Chair and has over 40 years of technical and management experience, including more than 36 years in planning, engineering design, construction, and modification for the nuclear power industry. He has extensive experience in project management, systems engineering, and systems analysis. Ralph is also the recipient of several ASME honors and awards, and he is an ASME Fellow. Dr. Thomas Hedberg is the current ASME Model-Based Enterprise Standards Committee Chair, in addition to leading acquisition and industrial security research at the University of Maryland. Tom conducts research in the areas of product design, manufacturing, and lifecycle engineering using information modeling, knowledge engineering, ontologies, system integration, and advanced optimization techniques. Tom, you're up first. Let's get started.
Hello, my name is Tom Hedberg, and I am the chair of the ASME Model-Based Enterprise, or MBE Standards Committee. I'd like to thank ASME and you all for the opportunity to briefly present some of the standards innovation we are deploying within the Standards Committee today. And I hope that you can take home some understanding of where the future of standards are potentially heading. Before we get started, I want to take a quick moment to say that I'll be presenting some draft MBE standards material today, and all the content that I do present is subject to change and must go through a rigorous ANSI accredited ASME review process. So just please keep that in mind as you see things. It may not be the final version that ends up getting published, but we are making progress and getting close to releasing some of our initial standards. So let's dive into it. Right, the bottom line up front is the MBE charter, or what the standards committee is really focused on, is about developing standards or related products that provide the rules, the guidance, the examples for the creation, use, and reuse of model-based data sets. It's really about data, right? We want to be able to link data across the product lifecycle, be able to have that use and reuse of the data. It's not just about creating digital data product definitions. It's about creating various different types of data, bringing that data into different types of models and being able to link that together across that. Our scope right now is really focused on recommended practices and requirements for the creation, the exchange, and the use of those models within the mechanical engineering discipline, right? So we're not going to do electrical engineering and those sorts of things. It's really about mechanical engineering, because we are ASME, and we want to look at how we can include the interface of mechanical engineering to other engineering and business disciplines. So while we're not writing standards specifically about other domains like electrical engineering, civil engineering, those sorts of things, it's about how could mechanical engineering, through the use of models and model-based enterprise, link with those other domains. So why a model-based enterprise? Really, this grows out of that we're seeing digital transformation across the enterprise and throughout the entire product lifecycle, right? If you are paying attention to some of the trade magazines and really sort of the push of what solution providers are offering in software today, it's all about this idea of digital twin, digital thread, right? Really enabling that digital transformation using data to drive a lot of things, right? So what we've noticed is that with the ASME standards, we need to go beyond digital product definition, right? This DPD, things that you see being developed within the ASME Y14 standards committee. And we need to get to a systems level thinking about how do the different phases of the life cycle, how do the different functions and roles within that life cycle link together. And it's right, we needed to manage these complex integrations across that suite of functional domains. And then lastly, we saw that there's a need for standardization around data-centric communication, especially in these distributed, federated, and linked enterprises. Manufacturing today, the production environment, supply chains, they all are not located in one location. They're not all in one system. They're not all in one server or software package, right? So they are now inherently distributed and federated across geographical locations. And the goal is to link those together to be able to better realize the benefits of that information and help streamline sort of our business processes. So the goal of what we're trying to do really in the Model-Based Enterprise Standards Committee up front is to say, how do we enable dynamic model connections, right? If I've got design, material, manufacturing, quality information that are housed in different sort of cylinders of excellence, how do I link that together, right? And it's about really how do I generate this concept of the digital information model, or what some call the digital thread, right? I want to be able to connect the color nodes of this chart of those four sort of functional domains, their data, their information together. And to do that, it's not just, you can't just simply draw a straight line and say, I'm going to connect those color nodes, right? It's about, I got to map the data between the different information sets, between the different functional domains. And that's what we're really trying to help, is say, what is the interface control point between design, between manufacturing, right? It's not just throwing a piece of paper over the wall or faxing it or emailing it anymore. It's about how do I actually provide the right information at the right time so that manufacturer can use the design information, or that the quality engineer can use that design information to be able to complete the job that they have. So keeping this all in mind, right, then the Model-Based Enterprise Standards Committee was stood up a few years ago by ASME to really, again, help enable that digital transformation for industry. But you may be thinking, well, what is in Model-Based Enterprise? Well, it's about really kind of going from where we are yesterday and today of using drawings, using documents to specify our products, to specify our standards and our and those sorts of things, to moving to this interdisciplinary environment where models are the source rather than the documents, right? It's about having rich computational information, right, that encompasses all of the business activities, right? And that you have these different classes of models. You can have something like a systems model, a product model, a process model, and you can see sort of examples of representations of those models here on the right side of the chart. So our committee right now is currently structured with 13 standards committee members who are sort of the steering committee of the efforts that are happening. We have over 90 plus members in a subject matters support group, which is how we draw, or what we draw from, to do work within our working groups and some of our work package teams, which I'll jump into that in a little bit here as I talk about some of how our processes work. But right now, this is how we're functioning. We've got a near-term strategy working group. It's really looking about how do we transition from today to where the future is going, knowing that some of our standards are going to be really future-looking. We've got a working group that's focused on developing processes for building our standards in model-based ways, in that, right? Because we have model-based standards that are themselves model-based and such. And then I'll touch on work from the framework and the interconnectivity working group as we go. Just a quick timeline. ASME stood up a steering group in 2018 to kind of look at what would a future standards committee in model-based enterprise look like. That steering group spent about most of 2018 putting together a report that was delivered to ASME in December of 2018, and in March of 2019 ASME formed our standards committee. So we've been around for just a couple years now. Really, you focus on trying to drive participation towards what does industry need immediately for model-based enterprise and such. So we put out some RFIs. We've been meeting virtually, specifically because of COVID, but also we meet weekly and bi-weekly, depending on working groups and standards committees, to really drive, again, that participation. And so we formed our working groups over the course of the last 2 years. And in May of 21, we actually had an agreement, or came to an agreement with the Y14 Standards Committee to generate a joint working group between Y14 and MBE to look at, again, the transition from traditional paper-based specification of product information to using only models in those processes, and really how do you leverage the standards that exist within the ASME codes and standards space and use those in model-only environments. But then in November of 2021, we released our first standard, our framework standard, for public comment, and that wrapped up just last month. So let's get into the meat of it, right? So the remaining time I have with you here, I'll be really talking about how are we trying to change the standards development paradigm, right? It's about, like, how do we really move the cheese of what standards are doing. One of the things we recognize is that you can't develop standards for model-based things without the standard being model-based itself, right? And it's a little bit of a chicken and egg problem here, right? Is that if I'm going to go tell industry, or if we're going to help industry sort of set requirements for how to use models to define a product and how to use those models then in the manufacturing process and to qualify parts against those models, right? I kind of need to have models of the standard itself. We can't have those models be built using requirements that are just written in a text document, right? And such. And so the goal here was about really helping build models of the standards that could potentially be used in automating conformance checking of processes and artifacts that are developed in the product lifecycle as part of the processes that are in a model-based enterprise, right? And so the goal that we're really focused on is this idea about increasing the integration between different components of the standard and speed up the development and releasing of those standards. And so as I kind of said in the first bullet, right, our development's done in models. It's not in words. So if you come to one of our standards meetings, you won't see anyone sitting around in a room just editing text documents as a group. Right? We're focused on building models. We're focused on sort of talking about concepts in somewhat abstract ways, but it's about really what is the entity and what are the relationships between the entities that make up the work processes and the structures that are within our standards. And so what we've done to really help, again, speed up that development process is we're taking an agile approach to building our models of standards. And so you see we have sort of a breakdown, and it's a little bit of an eye chart, but it's really a breakdown of how we kind of go through a structured way of identifying needs, putting those into sort of a set of requirements, defining the capabilities, defining the features that are that are realizing those capabilities, right? And putting together the user story on what is the purpose of these standards, right? Or what is the purpose of the concept or the capability, the feature that's being enabled by the standard, right? Making sure we put that into the end user and really keeping in mind that end user's need so that we can satisfy that and make the standards relevant to our end users. And so just here on the right, you see that we have kind of we use sort of a Kanban board approach. We've got tools in place where we actually develop out our epics, we capture our action items and our tasks, and we walk through the process, making sure that we have a healthy backlog of work that we are always able to keep moving forward. But the way we also do this too is we generate work packages, and so what we're currently developing is an approach for having anyone really, whether it's in the standards committee, our support groups, or the public, be able to put forward a need statement and propose a body of work that can then be going into our standard. Again, the model is our standard. So with that being said, right, we don't have separate documents for each components of the standards. It's a monolithic, large sort of network of entities that have relationships to one another. Those concepts are linked together with the definitions within those models. So we, through that agile approach, right, we can kind of just keep enhancing, enriching, and expanding the model to cover more needs, add more capabilities, more features to our standards. And so through the work item package, right, this is a way for us to capture what capability is needed and what the value statement is for that, but then also really identify, do we have the resources to get this work done, right? Who's going to be responsible for driving that work package to completion? Who's going to own it? Who's going to architect it? Who's going to help with modeling it? But then we also want to put it on a schedule, right? So we want to say, how long is it going to take? Is this body of work going to take 3 months, 6 months, 12 months, 24, or 36 months? Really, we want to try to stay to the left of that, right? We want to sort of stay in 3 to 12 month chunks, because that allows us to, again, move fast, get more capabilities and features out to end users within the standards, setting those requirements, walking through the stages. And so we also think that this is able to allow folks to who participate in our standards to be able to ebb and flow with their participation, knowing that someone's not always available to come to week-long meetings and that, but maybe they can find the time to meet weekly on a conference call and work through a work package, or pick something up, come back with a small team and walk through an approval and review process to enhance those models. The way that we're supporting all of the work that we're doing is through our standards development infrastructure. So because we're using models, right, we've set the requirement that our standards must be readable and understood by computational systems. That means not just the human has to be able to read it, but the computers have to be able to read the standard as well. And to do that, we're using the No Magic technology stack. We're doing our modeling in Cameo and Magic Draw for all the modeling. We're capturing all of our development work. All of the models are being housed in Teamwork Cloud for our model management collection to do all the version control and integration at that level. We've decided that we're going to use SysML, the systems markup language, as our common language or our standards language for developing our models and the standards and such. And so through that, the way we're developing our standards is using a model-based standards development methodology, right? And so I know that this gets a little confusing at times where we talk about, well, are you standardizing a standards process, or are you standardizing something for industry? And the answer is really both, right? We've got work where we're developing common practices for how we develop standards using models, but that really the end goal of the standards committee, as I said right up front, is that we are really trying to help build standards for model-based enterprises, and right, enabling that dynamic information flow, that dynamic information integration across the product life cycles. So our development methodology includes a standards development policy, standardized languages, processes for verification and validation, configuration management, and then how we deliver all of that. What are the normative sources and such? On the right, you see just an example of some of the ways that we can develop or capture the standards, right? Our model repository there, you see in the top right corner, that is our Teamwork Cloud. You have the model there on the top left corner, and then in the bottom right is a rendering of the standards in both text and diagrammic form, right, from the model. So what you typically get when you see the PDF or get a printed booklet of an ASME standard, it's all text, right, with figures and all that, and that's a standards committee really kind of going through and typing all that up. We are going to let the model basically publish that text, right? That will be rendered from the model. All the documentation in the backup for a human readable form will be coming from the model, but then the model itself, the normative portion of our standard, will be available for sort of computational integration, right? That is, again, being read by a computer, potentially, again, automating standards conformance checking and such, right? Hey, did I build this model correctly? Did I organize this infrastructure properly? And so on. So let me take just a couple minutes here to give you a show and tell, right? So our MBE framework is our first standard. This is really where the standards begin in our mind, right? The goal here is that we use the framework to define the concept of an MBE, or a model-based enterprise, and its elements by providing high-level structural definition. And so if you look on the right here, right, we kind of have a responsibility pyramid here, in that we say that the ASME MBE Standards Committee is going to be responsible for a framework and model-based enterprise architecture, and then specifications of the concepts that are defined inside that architecture. And then it's up to the standards adopter to decide how they want to implement and satisfy those specifications. Right, but as you go down that pyramid, you get more level of detail in the standards, right? So the framework is really meant to be abstract, high level. The scope of it is an architectural view of an MBE and its constituent systems, right? And we're using the ISO 42010 standard for how to capture those architectural concepts within the framework. And the intended audience for this initial standard is standards developers, it's for MBE solution providers, and it's for practicing systems, MBE systems architects, right? So for those who have to actually, in industry, in practice, right, have to figure out how they integrate their design and manufacturing systems, right? This is intended for those people. Those people are working in like sort of the engineering operations, the information systems space within your companies. And such, knowing that we'll eventually get to other stakeholders, but that's some of the initial process or the initial audience that we're focusing on with the framework before we move into developing out the architecture. The other thing too is it's about really helping use the framework for enabling the standards adopters, right, to quickly discover within the MBE architectures and specifications where they belong, right? So not everybody doesn't focus on everything, right? They have a functional role to play in an organization. We want to be able to use the framework as a roadmap to getting to the requirements that those people need to address, right? So as I said, we're using 42010, right? It's made up of stakeholders who have concerns. They have those concerns have have an interest in a system of interest, right? That system of interest exhibits an architecture and so on. I'm not going to dive too much into this. It's a little technically deep, but just understand that we're really focused on making sure that we can textually capture the concern of stakeholders, right? So here you're seeing the model for the framework standard within the MBE framework. This is, again, stakeholder has a contextual concern which conforms to a certain viewpoint. We have a list of viewpoints we've identified, right? That stakeholder takes responsibilities and they perform a role with that given viewpoint. That contextual concern, right, then drives an interest in a particular system of interest, whether it be from the conceive domain, design, realize, like manufacturing, service, which could be something like product support, or the end of lifing, right? And that they use resources, they use a capability, they use a model, they use an artifact in addressing or in performing their role within that viewpoint for that contextual concern. As we also do the modeling of these standards, right, we want to provide recommended practices. So the goal is not just say, hey, here's a model, right, go do something. It's also then, hey, we're going to give you a recommended practice, and we're going to talk about how to use use case scenarios, right? We're going to say, so I, as a stakeholder, I want some feature so that I can do something, right? I'm going to provide a story, which could then allow you to drive into developing model use cases, right? This is where we get in the meat of then really identifying what are the requirements that need to go into the standard for addressing stakeholder needs of industry and really creating those interface points between the different functional viewpoints of the life cycle, right? So here we are showing a design failure mode effects analysis use case. You see three stakeholders there: an engineering manager, a design engineer, a service engineer. They have different viewpoints, right? This is coming from the design system of interest sort of context, right? And there's a set of activities within that use case. And what we can do then is model out each one of those activities, which allows us to then identify artifacts, identify models, right? Those resources that you saw in the framework. And what this allows us to do then is say, hey, we've got all these artifacts, these models, these resources, these capabilities, right? We can then go and decompose those into a set of specifications on what is that model, what is that artifact, what is its input and output and its requirements from that point. So it's really about making sure that we address stakeholder needs through capturing use cases and the activities that those stakeholders have to go through to perform their functional roles. So in closing, just wrapping this up, the ask is really the current standards committee and our SMEs, our subject matter experts, we're heavily affiliated with the aerospace and defense industry, and a lot of us come from the design and product development roles. We want to try to recruit, and what I'm asking for the public is if you're interested in model-based enterprise, really enabling that digital transformation, we want others from other industry sectors, other roles. We want oil and gas, automotive, medical, biomedical as some examples, but also then those coming from manufacturing, sustainment, or business operations side of those enterprises. We want those folks to get involved, and we really do have a need for more enterprise architects with modeling enterprise expertise to get involved, to help us build out the standards of the models and such. So if you want to learn more, Fred Constantino is our ASME staff secretary. You can reach out to him here. Michelle Pagano also supports us. The two links here go to our CNS Connect page, as well as our collaboration site that we use for putting out newsletters and just sort of general announcements to the public and such. But I hope this just gives you a real high level view of what we're doing to really push the envelope for how we develop standards using model-based practices for model-based enterprises, right? And how we define model-based enterprises using those models in the standard and such. I thank you for your time. Thank you for your attention. And I'll turn it back over to our hosts. Thank you.
Great. Thank you, Tom. Appreciate it. It looks like we do have some questions coming in. As a reminder, if you have questions for either speaker, you can type them into the Q&A box within this Zoom screen, and we'll address them at the conclusion of both presentations. Ralph, I'll now turn the floor over to you.
Thank you, Frederick. I'll share my screen. Hello to all the participants. Just for your information, because I think the question will arise in your minds, is whether the material that Tom shared with you about the MBSE committee is Excuse me, I don't know what that is in the middle of the screen. We have both started around the same period of time, and we just recently found out about each other's efforts. So our topics today will be about model-based systems engineering and using it as a tool to write a standard, for actually writing a standard. And its presentation will provide an overview of the purpose, scope, and objectives of the standard. And then we'll do a walkthrough of the standard in its current state within the model-based systems engineering tool. The standard is the ASME Plant Systems Design Standard. It's a technology-neutral standard for design of facilities with the potential for significant hazards to the health of the public, the worker, and protection of the environment. It also includes nuclear facilities, including power generation, as well as fossil power generation facilities, coal, natural gas, etc., oil refining, oil and natural gas production, petrochemical, chemical, and hazardous waste plants and facilities. So we have a pretty broad scope. The standard provides a framework, including requirements and guidance for design organizations to do primarily three things. One is to incorporate systems engineering practices and tools with traditional architect engineering design processes, practices, and tools. Conduct plant process hazard analysis in early stages of plant design that do two things: advances the design matures and provide structure to initial development of a quantitative risk assessment if the industry or regulator requires it. And thirdly, incorporate risk-informed probabilistic design methodologies with the traditional deterministic design methods using reliability and availability targets. Our objectives are safer, more efficient designs and design alternatives with quantified safety levels. We can't do that necessarily in our current deterministic design methods. More effective requirements management to address the entire life cycle of a plant from design through construction, operation, contamination, if necessary, and decommissioning. And to be system-based versus component-based, and to cover multiple disciplines: mechanical, electrical, instrumentation, HVAC, etc. Now, this approach is a fundamental change because historically ASME has not promulgated systems-based standards. So being system-based, however, allows the standard to also be process-based, which is another fundamental change. And since it is process-based, a model-based systems engineering tool becomes an ideal platform for promulgating the standard. Our tool is Innoslate, a collaborative cloud-native tool released in 2012, developed by Spec Innovations, that's their systems and proposal engineering company for Spec. And they've been a leader in systems engineering since 1993. Please don't try to read this chart. It's really an eye exam, but it'll give you an overview of what we're doing. So we found a cloud-based tool necessary model-based systems engineering tool necessary when trying to get several committees and their members with global participation on the same page. And the work needs to be transparent and current to all participants on the committees. The process of trying to share files via email or shared drives is not very effective for configuration control. And the Microsoft Office tools just are not up to this type of a task. We're using the Innoslate tool to do the following: develop functional diagrams. You'll see that here. That represent project processes that will be addressed in the standard, show the interrelationships between and among the processes and the associated document sections. Collaborate with all authors, regardless of where they are on the globe or what time zone they might live in. Make all information transparent to all authors. Provide a standard set of terms, taxonomy, and way of representing the data. And most importantly, write the sections of the standard in the tool. And you can see here is a depiction of how we're actually writing the sections in the tool. Our progress to date in the first year, we did detailed planning of the contents of the standard. We began with an in-person and Zoom brainstorming sessions to develop a roadmap for each of the three technical areas. The roadmaps were used to develop work breakdown structures and data sheets with descriptions of each part of the standard and identification of inputs and outputs from one part of the standard to the other. We use block flow diagrams and square diagrams, which you see here, to develop, integrate activities within each technical area and to integrate the technical areas together. We imported this information into Initiate to plan and organize contents of the standard. Actually, it wasn't just importing it. In many cases, we developed it within Initiate. In our second year, we began writing. We developed part one, general principles, that provides the scope and applicability information, describes the boundaries of the design activities that are included within the standard, and a detailed description of the taxonomy and baselines that are used. Also describes use of the standard relative to regulatory conformance, occupational health and safety, risk-informed, performance-based design, and others. It also includes design process overviews for each of the three technical areas: systems engineering, risk evaluation, and probabilistic design. In parallel, we began writing part two, the design development processes. This part of the standard provides requirements and guidance for the three technical processes, including methodologies and tools. This is the bulk of the standard and the heart of the standard. The focus of and balance of this presentation will be focused on part two. But before we go there, we need to talk about a few concepts using the standard that you need to be aware of. Those are boundaries, taxonomy, and design process overview. We will cover these in the next few slides briefly. So this slide depicts our boundary diagram. It's included and explained in part one of the standard. As you can see, we're heavily influenced by ISO, 15 process groups, so that up here the standard, technical management processes, technical processes, equipment processes, and organizational project enabling processes. But many of these process groups are not included within our scope. We state in part one that all the process group activities are essential, and I underscore that, essential to a successful project. However, this standard only addresses a subset of the technical processes, and we see that outlined by the red box. Now, there are multiple points of entry into use of the standard. We're using the dashed red boundary line to depict this. This line may move up or down depending upon the technical information provided with the contract at the start of the project. For example, many of the petrochemical and next generation nuclear plant designers are performing stakeholder needs and requirements definition themselves. In other situations, a design organization may be required to perform stakeholder needs and requirements definition. And so this line would move up and down as appropriate. Part one of the standard addresses these alternate starting points for use of the standard. This graphic illustrates the taxonomy established for the plant systems design standard. It might be quite different from what you've seen before or used. Since our standard is applicable to a wide range of industries and disciplines with varied terminology in each of those, we found it necessary to develop a taxonomy to establish a common language. And it's represented here in this graphic. We can see that the site, infrastructure, and plant are the highest level. It's composed of a plant, there might be more than one, and the infrastructure to support the plant. Below that level, the taxonomy looks probably more familiar with the identification of systems, structures, subsystems, components, etc. In addition, structures have a leg of their own, in that the taxonomy, since they're specified differently than the process systems usually are. This graphic also shows which level of taxonomy is the focus of each baseline, defining and specifying the functional requirements and architecting of the site infrastructure and plant level, as highlighted in fully shaded in black. The system structures and site grading are a focus of the allocated baseline, which is outlined with a black box. and the specification design of items that are fabricated or constructed on the output of the product baseline, shown with just the normal boundaries. Some other examples of these items are included in the graphic, so stormwater, process system handling, utility, etc. This is a plant system design process overview diagram. The left-hand column identifies design stages: conceptual, preliminary, detailed design. The process begins with the receipt of the contract. Get this out of the way. Your contract technical requirements. Then initiate start of conceptual design for the site, infrastructure, and plant level. You go through what are the functional performance requirements for these three big black boxes that make up this level. What are the hazards? Evaluate those hazards. You look at your frequency consequence curve is typically developed at this stage, as well as your high level of safety function. The completed conceptual design is then the technical basis for the functional baseline, which is the input to start a preliminary design. And the process is repeated for preliminary design of systems and structures, and then later for the detailed product design. So now let's start our walkthrough of the standard as it's being developed in InnoSlate. This is what we call our route diagram. It's a view of the top level of activities addressed in the standard. We thought that previous chart was an eye chart. This is much more so. Most of these activities are further decomposed. The focus of the top row is on stakeholder related activities. The second and third focus on requirements definition and actually design activities. The risk evaluation related activities are the focus of the fourth row of activities. And finally, the fifth row shows the probabilistic design related activities. The white boxes you see are the activities, while the green parallelograms represent inputs and outputs from the activities. This is a bit more detailed view of activity H3 to evaluate site infrastructure plant risks. These risk evaluation activities support the development of the conceptual design. And as I said earlier, the conceptual design is documented in a functional baseline, which is the basis for beginning preliminary design. And each section of the standard has 5 parts. The first part you'll see here is provides text describing the activities to be performed, including the supporting sub-activities, which we affectionately refer to as child activities. In this part, the author describes what the activity is, its purpose, its relationship to other activities, and the inputs and outputs to and from other activities. Similar paragraphs are used to describe any child activities. A general description of how activities are performed is provided, but detailed how-to information is not. We use a toolbox to identify references that provide the detailed how-to information. As you can see on the left side of the slide, InnoSlate helps to manage the relationships between requirements, between parent activities, child activities, etc., and managing the inputs and outputs. All authors can see these relationships as well as the descriptive text, which help them write their section in an integrated manner in context with the other sections and other authors. Here we say activity H3 evaluates site infrastructure plant risks. The second part of each, or the diagram, the second part of each section is the action diagram. And it's to link to the data within InnoSlate. So if the data changes, the diagram changes. And the third part of each section of the standard is the requirements table. It too is auto-generated from the data within InnoSlate. When I say auto-generated, I mean it's because the database includes an entity class for requirements. It's independent of the entity class for actions, and the database links those together where appropriate. The authors use InnoSlate to relate requirements to actions, and the table is then auto-generated based on those relationships. The fourth part of each section is the inputs table. Since inputs and outputs are also an entity class, the input table is also auto-generated from the data within InnoSlate. We can see here that there are two descriptions that are missing on the inputs. Those are still being developed. You can also see that there's some formatting issues in the description, and Spec Innovations is working on us to fix this. And finally, the fifth part. Get back to where I should be, excuse me. The fifth part, and initial and final part of each section, is the output table. It too is auto-generated from the data within that slate. And again, you can see some formatting issues. However, formatting is correct within the tool and the description in the tool, as you can see here. So it's just an output or element that we're working on. Now, within the tool, we've created a writer's guide to be used by authors of the various sections of the standard. This is what you're seeing, the part of the guide for activity numbering. We have similar guidance for requirements numbering, input-output numbering. And having the writer's guide is essential to maintain consistency and integrity of the data within a slide and the writing style. So when we complete our work, it sounds like it was all written by one committee working closely together. Also within the tool, we have our list of terms, acronyms, and definitions. If you note the right-hand column for discussion, since our standard is applicable to many domains and industries, there are many terms with similar or slightly different messages or meanings in petrochemical, nuclear, et cetera. So this fourth column is where we recognize these. We basically say, this is a definition we're using in the standard, but here's some other definitions as related to other industries. A good example is, from an acronym standpoint, is environment, safety, and health. Should we use the acronym ES&H, HES, or ESH? We obtain a consensus from our committee members and then include the term, its description, and discussion in the slate, where it's available for all authors to use globally as they write their sections of the standard. When you open in a slate, you first see the project dashboard. It can be tailored for each user using widgets. In my dashboard, I include comments, feed, route diagram, and activity feed. I also have the writer's guide not shown here in my dashboard. So I can monitor all the comments being made of different sections, who's been doing what and making changes. And of course, the tool offers full information management controls, et cetera. And we did it in a database format with different entity classes as shown here, or graphically. We can graphically add actions and IOs as well as different development sequences. In the diagram on the right, you can see 4 child activities that are performed in parallel. And there are many ways to view the data. The action diagram is shown here. We can also view as an N square, a spider, and many other types of documents that are available. There are many ways to report the data. Here you can see the pull-down table that offers different types of reports for both content and format. I frequently use the entity table report that allows me to pre-select the data fields that I want to see. So in summary, as far as we know, this is the first project to promulgate a standard using a model-based systems engineering tool. You can see we've come a long way. We still have a long way to go. If you would like to participate, please contact me at the email shown here or at the phone number. And I live in Las Vegas, so I'm on Pacific time. Currently, I'm in Bariloche, Argentina, but I'll be returning in March to Las Vegas. Thank you for your time. I'll turn it back to Frederick.
Attending, looks like some of the other questions that were coming out are, one is about the VVUQ effort in pharma and bio, and we do have the ASME VVUQ 40 on medical devices, which also addresses simulation modeling and computational modeling. So they are doing other efforts. And also to seeing some of the other questions about participation. Anybody can participate, student, professional, whatever. If you have interest in this, you can participate. Just reach out to myself or Jamie, or even the chairs that the speakers today, and we'll help get you involved. Meetings are virtual to attend. They're free and open, even if you can't attend in-person meetings. But if you can contribute somehow, we'd welcome you to join in. So I'll turn it over to you, Jamie. And thank you, everyone, again.
Thank you all. Before we wrap up, I'd like to mention that if you're interested in obtaining a PDH certificate or would like to request a Tech Talk topic, look out for follow-up email if you've opted into receiving communications from ASME. If you have colleagues who were not able to join us for this Tech Talk, it will be posted within the ASME's member page for the Tech Talk series, typically within 1 to 2 business days. The next Tech Talk will be presented by the International Gas Turbine Institute on Friday, March 18th at 10 a.m. Eastern Time. Additionally, if you are a member, an ASME member, and would like to join a division, visit asme.org and log into your account. Click on Additional Info. Here, you can select up to 5 areas of interest by clicking Edit next to Technical Division Interests. By doing so, you will become a member of these entities. Thanks again to everyone for joining us today. We hope to see you again soon. Bye for now.
Thank you.